Distributed Processing in MapReduce. Introduction to MapReduce. MapReduce is a programming model that processes and analyzes huge datasets logically into separate clusters. While Map sorts the data, Reduce segregates the data into logical clusters, thus removing the bad data and retaining necessary information. Why MapReduce? Prior to 2004, huge amounts of data were stored in single servers. If any program ran a query for the data stored in multiple servers, logical integration of the search results and analysis of the data was a nightmare. Not to mention the massive efforts and expenses that were involved. The threat of data loss, challenge of data backup, and reduced scalability resulted in the issue snowballing into a crisis of sorts. To counter this, Google introduced MapReduce in December of 2004, and the analysis of datasets was done in less than 10 minutes rather than 8 to 10 days. Queries could run simultaneously on multiple servers, and search results could be logically integrated and data could be analyzed in real time. The USPs of MapReduce are its fault tolerance and scalability. Let's look at a MapReduce analogy. The MapReduce steps represent manual vote counting after an election as an analogy. In step 1, each polling booth ballot papers are counted by a teller. This is a pre-MapReduce step called input splitting. In step 2, tellers of all booths count the ballot papers in parallel. As multiple tellers are working on a single job, the execution time will be faster. This is called the map method. In step 3, the ballot count of each booth under the assembly and parliament seat positions is found, and the total count for the candidates is generated. This is known as the reduce method. Thus, map and reduce help to execute the job quicker than an individual counter. The MapReduce analogy. Vote counting is an example to understand the use of MapReduce. The key reason to perform mapping and then reducing is to speed up the job execution of a specific process. This can be done by splitting a process into a number of tasks, thus enabling parallelism. If one person counts all of the ballot papers and waits for others to finish the ballot count, it could take a month to receive the election results. When many people count the ballot papers simultaneously, the results are obtained in 1 or 2 days. This is how MapReduce works.